All right, so we're talking about linear approximations here, and what you're attempting to do is approximate a y value on a function that you don't really know, but you happen to know, it's one of its tangent line at that location. And in a way, all you're kind of doing is you're taking a y coordinate on a tangent line, and you're moving slightly to the left or slightly to the right, and then you're kind of then adjusting that y value by adding or subtracting the slope that you know, so that you can then, in a way, make an estimate of a y value on a function. Okay, so basically, our classic tangent line equation, right? And if you take this function and sorry, this equation, and you change the y here to an L of x, then basically what you're saying is that y coordinate on that tangent line is now going to be a y coordinate, or a linear approximation they call it, of a function. Okay, so let's look at this diagram here. I've got in this diagram, here, let me pull this diagram up here and go like that. Oh, is that right? There we go. Okay. All right, so I've got in this diagram here, these this xo and f of xo are on the function, and they're on the tangent line as well, because that's the tangent point. Okay. Now, these little green arrows signify that it's a point. This is a point. These two green arrows, this x and the y, is a point on the tangent line. Okay, but it's just a little bit away from this point on the function. Okay, and so basically the y coordinate of that point becomes a very close, an approximation of the y coordinate on the function itself. Okay, and so L of x is basically this pink dot, and this green dot is the y coordinate, is a dot on the tangent line, right? So basically what we're doing is we're saying, all right, here's my tangent line, here's a y coordinate, here's a dot on the tangent line. It's close enough to the function, so I'm just going to say that pink dot is equal to, more or less, the green dot, which is why it's called an approximation right here. Okay, and so basically, let's go ahead and apply this to a few questions here. The theorem is placed up there. I've rewritten it here. Here's a question. It's 4.2, question 10. It says, use the given information and a linear approximation to approximate the value of the function at c. So you have to kind of, for these ones, you just have to remember which value goes where, right? So they give us the value of the derivative and the y coordinate. So this is the f prime, all right? And then this f prime of 1, sorry, f of -1 goes right here, okay? So those xo's, and then this ends up being an xo as well, of a -1. And then this c value is kind of like that x coordinate that you're saying is close to the actual tangent point. So in our question, this would be the green x, and this would be the green y value that accompanies that, which happens to be, in this case, -0.15. And so now what we say is the function has a value of -0.15 at c, or at x equals -1.1. Even though it's not true that it has that value, we're just going to say that it is close to that value, right? So basically what we're doing is we're saying we're taking this green line, this red line, we're building this green point, and then we're telling everybody, hey, since this is a tangent line, we're going to say that value is close enough. Okay, and basically here's number 9 as well, done, and it's done in the same way. If you kind of look at this closely, what you're doing is you're saying, let me take a y coordinate, and then I'm going to move over to an x coordinate just a little bit away. So notice the difference between these two x coordinates. This is just a little bit away, and I'm going to take that much of the slope and apply it to that y coordinate. So notice my y coordinate was 8, and now I've got a negative slope, but I'm only using it just a little bit, and so now my y coordinate becomes about 7. Okay,